Okay, so today we're going to be looking at the boom tube. What we're doing is we have a chamber that's sealed on one end and open on the other. We are pre-mixing the fuel, and we have two hoses, one that has compressed air, one that has fuel, and we bring them into a T, which is brought in right here on the end of the tube on a small jet. On the other end, we've got the igniter on the open end, and throughout the volume we have 5 thermocouples and 5 photosensors, so we're able to look at the propagation of the flame as it comes from the open end through to the closed end. We're going to be looking at the flame speed and the temperature of the flame, and we're also going to be able to look at, since it's a clear glass tube, the transition from a laminar flame to a turbulent flame. And as soon as it becomes a turbulent flame, you'll see the flame accelerate quite rapidly. So we'll go ahead and turn off the lights. You just heard it pop a little bit. We're going to run 3 different runs. We're going to start off with a lean mixture, and what I mean by lean is we have stoichiometric, but we're adding more air from the stoichiometric ratio. Then our second run is going to be a rich mixture, which is more fuel than stoichiometric. Then our third run will be a stoichiometric run. So I'm going to turn off the lights. And hopefully we can see this with the camera on the very end. And there we go. We had a flame begin, a laminar flame through the first half of the tube, and a turbulent flame as it accelerated. We get to see that transition kind of slowly on the lean side. So what we'll do is we'll let it run one more event at the lean side, and then we will go ahead and make adjustments and go to the rich set point. So what's happening is right now the tube is filling with air and fuel. You can see the flame begin on the igniter end. There's a nice blue flame surrounding the igniter. And what the igniter is, it's just an electric heat element out of a furnace or an industrial oven. So now that flame is getting bigger, and it will transition into the tube. And once it does, you will see the beginning of the laminar flame in the first half on the right side of the tube. And as it begins to accelerate, you'll see the flame become turbulent. So the time between these events is quite large. There's the laminar and turbulent. So on the lean side, you'll see that our frequency is quite large. There's a lot of time between each run, each event. Now what we're going to do here is I'm adjusting our air flow and our fuel flow to more on the rich side. There's more fuel than what's needed to be stoichiometric. Now you'll see that the frequency will increase. There'll be a lot more events, and you'll be able to see the flame as it crosses the thermocouples. It will actually heat up the thermocouple wire, and you'll see some ghost flaming like right there. Now visually the flame is out, but just like that event right there, you saw the thermocouple glowing red, even though visually by the human eye you don't see any flame. Using an IR camera, you would be able to see a lot more to this experiment. So now we've got the flame beginning at the igniter, and the flame transitioned quite rapidly from laminar to turbulent. And here again we've got our ignition, some flame beginning around our ignition source. it goes flaming through. I'm going to try to adjust the fuel in the air so we can get a stationary flame. It's kind of interesting to watch if we can get it to do it. We can see the flame. I didn't do it that time, but you can see the thermocouple glowing even though there is no visual flame. We'll let it go one more event here. We're also looking at our data acquisition, and we're looking at our flame speed and temperatures. Let it go one more, and then we'll go ahead and transition to a stoichiometric run here. And you'll see with the stoichiometric mixture, you'll see that why we call this the boom tube. It makes a very loud noise. As the flame transitions from laminar to turbulent, it accelerates and produces quite an audible sound. Now looking at our data acquisition, our temperatures are much greater than they were at the rich setting, and our flame speed is much greater. So the first half of the flame, the first half of the tube, there again we're able to see the laminar flame as it moves across the tube, and then as it transitions to a turbulent flame, it accelerates quite rapidly. Now we'll let it run one more event so we can watch the flame propagate through the tube and transition from a laminar to a turbulent. And that's our boom tube for today.